G'day comrade subscribers. So this is going to be a very quick video today, I think. So I want to do something else, and I just thought, I'll try this. But I've disconnected the original crystal, which is here. So yeah, I know it looks rusty, but it's actually just tape coating, just to protect it from, well, there's not much really there to protect it from. Anyway, I realized that I've got this. I've had this, I've never really used it. So function arbitrary waveform generator up to 25 megahertz. I thought, oh, what about if I try and generate the clock signal using this? Yeah, so I've been experimenting and maybe something interesting. So I've got it hooked up. So I've got it set up. I was trying a square wave, but I don't think it really makes any difference from what I've seen. So I've just gone back to sine wave. So I've got it set up for 14 megahertz and amplitude 4 volts peak to peak. Yeah, and then I've been monitoring the clock signal on the oscilloscope. So I'm injecting it here into one of the inverters, so pin 5. So I'm injecting it, so there's the crystal. I'm injecting it to pin 5 here, which then, so we've got about 14 megahertz going into here, then we get 7 megahertz out and 3.5 megahertz here. So I'm injecting it there at the moment, and well, for me it's interesting anyway. So I'll show you. I'll show you the oscilloscope. Okay, looking at the oscilloscope. So I'm measuring at the Z80 pin 6, which is the clock input, because that's ultimately what we want. So the waveform generator is set for 14 megahertz, 4 volts peak to peak, and the machine's powered on. So let's go pin 1, 2, 3, 4, 5, 6. So let's just auto that. I'll probably make it a bit bigger. Alright, so 3.5 megahertz, okay, but voltage peak to peak is 4 volts. So I remember when I was looking at yesterday, it seemed that we probably needed about 4.3 volts into the Z80. Right, so if I change the amplitude of the input sine, alright, so it's 4 volts, 4.1 volts, 4.2, 3, 4.4. The signal reaching the Z80 is still only about 4 volts. So that's 4.6 volts, 4.7. So I thought that was interesting. So we're at 4.8 volts. But we're still not getting anywhere near the 4.3 that we need to actually trigger something. So next I think I might put it as the input to the first flip-flop. So 14 megahertz coming out 7 megahertz. Okay, power on. Okay, so we've got input 2, pin 3 on the first. So 1, 2, 3, 4, 5, 6. Okay, so again, so that's coming out. That's going into the first flip-flop, which is then generating the 7 megahertz signal. So I wonder, what if I inject 7 megahertz? I should just try inject it right at the Z80, shouldn't I? Alright, let me try experiment a bit more. So, hey, surprise, yeah. I was going to work on my supersonic electronic mastermind, but this has been bugging me. So I removed the flip-flop that was responsible for halving the clock signal, so generating 7 megahertz and 3.5 megahertz. So that's the original Soviet chip there. Unfortunately, I've only got SEM4 HCT. SEM4, I don't have LS. Oh, I've got 74HC and HCT. So one thing I read that when you're using CMOS is don't have a pull-up resistor when you're using the CMOS. So I might disconnect that and see what happens. I checked the voltage here. It was 4.9 volts before, which seems to be pretty much what I'm putting in. So, but the output's coming at 4 volts, so something's disappearing. So I thought maybe it's just not generating. Anyway, let's see. Alright, let's see. Power on. Okay, still no video signal. Surprise, surprise. Let's check the clock. 1, 2, 3, 4, 5, 6. Hey! It's now too much. It's now too high. The clock's looking better though. 5.3 volts. Okay, that's too high now. Ah, Fangulo. Can't win. Channel 2. What if I reduce the voltage, input voltage? 4.9 volts. No, down to 5. But still, the difference between VCC on the Z80 and the clock voltage is going to be too much anyway, isn't it? So I think it can only be 0.3 volts. Yeah. All right. The voltage is better. It's just a bit too better. Too much better. All right. So, all right. I have to order some 74 LS, I guess. I'll just try and check the output from. I'm just trying to find another ground. Stand by. Okay, power on. Let's just check the output of the flip-flop now. I'm just trying to find a ground I can attach onto. So that'll be that one there. All right, so it is pin 5 is the 7 megahertz signal. 1, 2, 3, 4, 5. So that's 4.8 volts. All right, it's about 5 volts coming out of there. And the 3.5 megahertz is pin 9. So 7, 8, 9. 5.2, so it's even higher there. That's the 3.44 whatever. Yeah, 5.2 volts. That's too high now. It's a volt too high. Maybe I should put the... So I'll remove the pull-up resistor and the capacitor that was there as well. Maybe I'll put those back in. All right. Okay, I've installed the pull-up resistor and that capacitor again. But yeah. So pin 1, 2, 3, 4, 5, 6. So this is clock. Pin 6. So supply voltage is 4.99 volts. And the clock's coming in at 5.2. Well, it's varying, but yeah, 5.1. So, look at the address line. All the other voltages are now much higher. So that's pin 1, which is one of the address lines, isn't it? That's at A11. 5.4 volts, geez, okay. Were 4 volts before. What's that, A10? No, A12. Pin 2, A13. Pin 3. 5.36 volts, geez. Where am I? Bit weird still, isn't it, really? Yeah, those little spikes on the address lines. I'm still supposed to actually need to put pull-ups on the data line still. That's one thing I need to do. That's 4 volts there. Or 4.8, 5.2. Oh, geez. Jumping all over the place. That's pin 3? Pin 4. That's pin 4. That's A14. Pin 5, which is A15. let's just do that. Obviously A15 won't be addressed so much. And then back to the clock on pin 6. Yeah, 5.2 volts. I think it's looking better. But yeah, now it's, I don't know, is the clock fixed? But we've got some other issue now, perhaps. 5.2. What's the input voltage? VCC pin 11. Whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 11 there? Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, that's 5 volts, isn't it? Basically 5 volts. Maybe the clock is within spec now. It's some other issue. Let me just use the voltmeter. Okay, one last look. So voltmeter. So you can see we've got 4.99 is the supply voltage. So at the Z80, what's the supply voltage? Pin 11, wasn't it? I should just mark it on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's pin 11, and what's, I need ground, don't I? Is that ground? Ah, DC voltage. Yeah, 4.88, 4.87. 4.87, and clock was what, 5.1. So I think that's out of, yeah, the clock's too high now. I think the clock's too high. So yeah, I guess maybe order 74 LS 74s. Even though HCT is supposed to be compatible, but yeah, okay, blah, blah, blah. All right, so I'll order some 74. But the clock's looking much better, wasn't it? I think it's looking, the voltages are better. Let's have a look. This is where we're at now. So the pull-up resistor and the capacitor are now reinstalled. And the original SEM4 or SEM4 part has been replaced with a SEM4 HCT SEM4. So it's improved the clock, I think, but it's just now too high. So like I said, I did try pulling out, removing the pull-up and the capacitor, but it didn't make any difference. So interesting. Okay, now I'm going to look at my supersonic electronic mastermind, I think.